Hey everybody, today is going to be just a small extension from yesterday. Setup is exactly the same. When you see an equation, the A is the initial amount, B is the growth rate or decay, and X or T is always the time. All right, the time period. Some of you, I had trouble yesterday when it says like every week, then that means 1 week is a time period. If it says every 3 months, then every that 3 months is one time period. Um, this would be considered a growth. If you had to distinguish between both of them, this would be considered a growth because of the 1.32. It's greater than 1, so it's a growth. This would be considered a decay because of the 0.86. If I asked the question, hey, what is the rate of decay? You would not say 0.86 because it started off at 1. How did it get to 0.18 or 0.86? It had to be something to get there. It would be 14%. 1 minus 0.14 would have been in the parentheses to make it 0.86. So 14% would have been the rate of decay. So that's just an addition from uh, yesterday, or just a tweak. The other one is yesterday we worked with just strictly percents, you know, changing one plus or one minus, whatever the percent. But if it's not a percent problem, if it's a exponential growth or decay problem where they mention the word double or triple or quadruple or half or third, those are all they're all still exponential, but you don't put a one in front of them. You don't because they're not percent problem. This example, the ants are tripling every hour. If there are 9 ants at the beginning of the picnic, how many or how long will it take before there are over 2,000 ants? So this is where another little tweak here. So let's go ahead and write our equation out. Y equals the initial amount is going to be 9 because there are 9 ants. And since it's tripling, my rate is going to be 3. Notice I didn't put a 1 plus because it's not a percent problem. Here, they did not give us a time period, so we just make it X. So if it says, hey, write the equation for this, I don't know the time period, so I'll make it X. Here's where we've got to do a little bit of guess and check on the calculator. It says, how long will it take? All right, so they're asking what is X. So here, you just got to sit there and you got to plug in numbers for the X until you get it says about how long will it take before there are over 2,000 ants. So you just have to plug in numbers into that in for X until you get below 2,000 and above 2,000. So if you what I did is I took my calculator, plugged in the number, and I just guessed. I started off with 4, or I'm sorry, started off with like 5. It was way too much. I came back down to 4. So when I did it, this is between, and you would just say between 4 and 5 hours. All right. And again, it's just putting your calculator, guessing and checking until you get below 2,000, above 2,000, and that tells you how long it's going to take. The pesticide is halving the roach population every day. How long will it take for the population of 2,100,000 to get down to 10,000? All right. So again, our equation is the same. We have our initial amount of 2,100,000. Our rate of decay is halving, so it's going to be 0.5 because we're cutting it in half every day. X is our time period. I don't know how they didn't ask us, right? How many days it took. They just said every day. So there's our formula for that. Now it's the question is how long will it take? I'm just going to take my calculator and I'm going to plug in numbers in for X until I get to below 10,000. So I went in, I started off with 5. It was way too high. So I kept on going up 6, 7, and then 8. 7 is at 16,000, 8 is 8,000. So I know it's going to take between 7 to 8 days to get down below 10,000. All right. Easy day today. If you have any questions, go back and watch this again. It's same formula, just not using the one plus or the one minus. You're just using whatever number they tell you. Of course, we know that doubling is 2, quadrupling is 4, tripling is 3. So just watch and be careful and answer the questions. Have a good one.